My name is Louise Jansen. I'm with the Academy of Science St. Louis, and I am Director of Public Science Programs and Speakers for Science for the Academy. And before we get started today, just one quick reminder to please turn off your cell phone and or other mobile device or turn it on silent. We're very pleased to be partners with the St. Louis County Library to bring you tonight's Science in St. Louis seminar, Building Better AI, Why Data Quality Matters Most. For those of you who aren't familiar with the Academy, I'm going to take just a moment to tell you a little bit about who we are. We're an independent science organization supported entirely through community contributions. At venues throughout the region, we connect science and the community through free and or very low-cost public talks, science seminars and workshops, and trips and tours that feature scientists and engineering professionals with national and international renown. In addition to advancing the public understanding of science, it's our mission to inspire the next generation of scientists and science advocates, which we do by offering an array of free and low-cost opportunities expressly for teams, such as our Junior Academy of Science and the Regional Academy of Science St. Louis Science Fair and its Honors Division. The Junior Academy is a pre-professional STEM membership organization for students from the full range of academic backgrounds in grades 6 through 12. It offers hands-on opportunities in science, engineering, and medicine. Teens can attend unique behind-the-scenes explorations of leading engineering, technology, and science labs in our region and participate in science career-oriented field opportunities and challenging and engaging science competitions. Junior Academy members make real-world connections by meeting top STEM professionals. You can find more information on the Junior Academy and all of our community-wide science events and programs by visiting our website at academyofsciencestl.org. You may also visit us on Facebook, Instagram, and LinkedIn. You may want to sign up on our website, again, at academyofsciencestl.org to receive Academy e-news, or jot your email address down on the e-news sign-up sheet that's in the back of the room, or on the audience survey before you leave tonight. So we do ask that before you head out this evening, we have some surveys that are sitting on the back table and some ball pencils. So if you could fill those out and let us know what you thought, it should take you a minute or two. There's also a QR code back there, so you can snap a picture of that and fill it out online as well. Be sure to mark your calendars for the next two talks in the Science in St. Louis series with the St. Louis County Public Library. On Tuesday, February 3 from 6:30 to 8 p.m. at the St. Louis County Library Clark Family Branch, we have postdoctoral research associate Dr. Elizabeth Carlin with the Department of Biology at Washington University in St. Louis, and collaborative biodiversity postdoctoral fellow with the Living Earth Collaborative, which is a Washington University, Missouri Botanical Garden, and St. Louis Zoo Research Consortium. She'll be speaking on how humans shape life from naming species to driving evolution. And then on Tuesday, March 5, from 6:30 to 8 p.m. via Zoom, we have Badri Adhikari. He's an associate professor in the Department of Computer Science at the University of Missouri St. Louis, and he'll be speaking on how AI is changing teaching and learning, or is it? You can find more information on those talks on our website and the library's website as well. Your being here this evening helps us to realize the Academy's vision of advancing St. Louis as a scientific powerhouse where science is trusted and scientists thrive. So we're glad that you're here with us tonight to learn about some of the science happening in St. Louis. All that said, I'm going to introduce our speaker this evening, AJ Segal. AJ is the AI-centered lead for public sector operations at Scale AI, a technology company that builds the infrastructure for the world's most ambitious artificial intelligence projects. In this role, he leads a St. Louis-based data annotation workforce of over 200 data quality specialists to accelerate the development of AI applications for the U.S. government. Prior to his work with Scale, AJ served on 20 years active duty in the U.S. Marine Corps, where he deployed 3 times to Iraq and Afghanistan, supporting Operations Iraqi Freedom and Enduring Freedom. AJ was also assigned overseas in the U.S. embassies in Abu Dhabi, United Arab Emirates, Pretoria, South Africa, and Nairobi, Kenya. He served as a military police officer for the first 10 years of his Marine Corps career, with a wide range of experiences, including commanding a ground combat element of over 300 Marines, serving as a strategic planner for a Marine Air Wing, and planning battalion-level operations in 1st Marine Division. For the second decade of his career, AJ transferred to being an intelligence officer with a focus on strategic human intelligence activities. During this period, AJ collected human intelligence to support the U.S.'s national and strategic intelligence requirements. He has his Bachelor's of Science in Management from Tulane University and a master's degree in Business and Organizational Security Management from Webster University. We are very pleased to have him here with us tonight for Building Better AI. So won't you please join me with a big round of applause and welcoming Mr. AJ Segal. And AJ, I'm going to turn it over to you.
Thanks, Rose. Thanks, Rose, and to the Academy of Science for giving me the opportunity to speak with all of you today. So Rose gave you the introduction. I'm originally from the Washington, D.C. area. Grew up there, had the idea of going to college and then later on joining the Marines. After about 20 years, my wife, where I met my wife during those 20 years, my wife, who's actually a Missouri native, and went to SLU here. We spoke about where we wanted to end up, and we were really excited to come to St. Louis and with the explicit purpose of joining Scale, because we're really excited about the mission that Scale is doing here in St. Louis. So today we're going to talk a little bit about, I'm going to go through kind of big to small on AI and why data matters to AI. And then towards the end of my talk, we're going to go, I'll pull up a couple models and we'll see how they do with some of these challenges that models go through every single day with AI and with the data that they're presented with. And then we'll end, and I think Rose has some refreshments in the back, but we'll also end with, I've brought along one of our subject matter experts for geospatial intelligence, Dustin Treasy here, who's going to go over exactly how data labeling works when we do data labeling every single day in our AI center. And we have some laptops set up in the back there, courtesy of our office manager right here, Aaron Orban, who's in the back there, who set all these up. And so we're going to give you all a chance to have some hands-on computers and spend a couple minutes actually seeing what data labeling looks like and how that all goes. So without further ado, I think to begin with, just to kind of understand for the room here, how many people use a large language model on a daily basis? Okay, so it looks like about half the room, excuse me. How many people say they use it on a weekly basis? A few more. And then how many people have never used one before but are interested or curious to learn more? That's fine too, yeah. I think, hopefully as you walk away from here, you feel a little more confident in why the models that you could interact with or do interact with give you the answers, and why you can trust them to an extent, and where there could be limitations. And we'll go over all those different things. So to start off with, I think I want to take a moment to talk about what brought me here to St. Louis, and that is actually our AI center that we have in downtown St. Louis at the Post building. So the AI center moved to the Post building in October 2025, but we've been in St. Louis for over 4 years at this point. I'm very proud to say we won the St. Louis Business of the Year award this last October for 2025. Really proud of that. And the reason why is because over the last 4 plus years here, we've brought over 200 jobs to St. Louis. And these jobs are folks, these are not coding jobs. These are not necessarily jobs these are more non-traditional tech jobs, where we have people that are working with geospatial data or doing generative AI writing every single day. And the work that they do helps the U.S. government accelerate its adoption of AI. And so within our center, every single day, we have folks that are working on everything from GeoInt autonomy to generative AI writing. It's really kind of interesting. Our workforce consists of a lot of people that are very good at spatial awareness, which tends to be artists, actually. So we have a lot of people who are, if they're good at artists, or if they're good artists, or they're good at doing puzzles, they tend to be very good at geospatial AI. And then we have folks who are writers, and these are people who do a lot of, it's kind of military style writing, but it's not people who are veterans, although we have a large veteran population. They are actually people who have an ability to do technical writing. And so with each of those, skill sets, we actually have partnerships that we have with University of Missouri St. Louis and Webster University, where those folks are now taking college courses at those universities, and they get credits for the time they do at our workforce. So we have a really cool team. And the really interesting thing about our team is those folks a lot of them joined Scale in 2020, 2021, when AI was really just coming up there. And so we like to talk about the fact that our workforce, our people, are really pioneers and not followers. These people have been on the forefront of working with some of the world's leading AI models, and it's really impressive the things they do. So today I'm going to talk to you about to go a little bit big on AI as a whole. Today I'm going to talk to you about what is fundamental to the future of AI, which is data quality. So we hear a lot about AI models, ChatGPT. We've probably all heard of them. ChatGPT, Claude. You hear about self-driving cars. My dad sent me an article from the New York Times about autonomous vehicles and how they get trained. You hear about image generators, but the unsung hero about each of these different AI models that exist today, the true backbone of these systems is the data that they learn from. So my goal tonight here is to convince you that while the models are important, the data quality is what matters the most. So for the next 30 minutes, we're going to go into the basics of AI, deep dive into why data quality is paramount, looking specifically at how it impacts both like the large language models that we deal with. So when I say large language models, for those that don't necessarily hear the term all the time, that's your ChatGPTs, Claude, Gemini, each of those. And then we'll go into some of those models that you deal with every single day, as well as the computer vision systems that are revolutionizing the industries. So after that, I'll take some questions, and then give Dustin a chance to talk about what's going on in those computers on the side, and then give you all a chance to kind of cycle on through those computers on your own. Now, so when we talk about AI, there's a wide range of definitions and knowledge here, but this boils down to computer systems learning to do human things. So you have the textbook definition on here, and it's basically it's computer systems performing tasks that require human intelligence. So what's really interesting about computer systems is it actually is really tough. There's things that humans are innately very good at that computer systems are actually not. And so the fact that AI is becoming better at this is the idea of becoming better at this. It's very impressive, the leaps and bounds that we've made over the last 4 years. The challenge with all of this is what's brought probably a lot of you out here is that AI has kind of become a bit of a suitcase term, right? It's a buzzword. Everything is AI powered. Everything is, I think you go to McDonald's these days and it'll say like, order from our AI powered menu or something like that, because everything is AI powered, right? So since June 2020, AI has really exploded into the world. It's a buzzword. There's a whole bunch of different terminology. You hear about it. And, we've captured some of these things here in this slide, but there's a lot of things. So I'm going to go into some of the more basics of it to try and help you to think through and how this all works. When Scale talks about AI, we talk about the 3 pillars of AI. We have data, algorithms, and compute. I'm going to go from bottom to top because it'll make a little more sense. When you think compute, those are oftentimes the chips that power AI. Probably the term you hear a lot is GPUs, and the most commonly heard of company would be NVIDIA. Next, you have the algorithms. This is oftentimes what you all will interact with every single day when you're thinking about when you're talking about the large language models or ChatGPT. Those are the algorithms that you interact with when using AI. But the reason why when you ask ChatGPT a question, when you ask ChatGPT for a recipe for how to make eggs, the reason why is because of the high quality data sets that have been used to fuel these models. Scale, as a company, we exist here in the data portion of helping to create these high quality data sets and build reliable AI systems for the world's most important decisions. Now, as you look at these as you think about all these and you look at the data, and the thing that we hear about the most, when you think AI, for around the room, someone can speak up, but like when you think AI, what's the first application or whatever that comes to mind? What do you think? Do you think data or do you think of a model? Who can name something for me? Gemini, great. Who else has got something that uses AI, or at least that uses AI? ChatGPT, yep. I've thrown a few of them out there already. So you've heard these terms. The challenge is that like when you think about the models, really it's is it the wrong shiny object? So people see these models and they think of chasing the best model. And so the most performant model is what we hear about and is what we talk about. You hear about the newest ChatGPT version, the newest Gemini version does this. But in this slide, credit to our to Scale's head of data engineering for creating this slide, because it really captures it perfectly, where it's easy to focus on chasing that shiny object, which is the best model. But the challenge is that models eventually go bad, or because data will become outdated, real world data changes. So the real value is what's here below the waterline. I know it's kind of small font, so I apologize for all those that may be in the back. But the bottom line is that what's happening under the hood of the car or under this waterline is everything to read out. It's data collection and pre-processing, continuous training pipelines, evaluation and monitoring, deployment and orchestration of models, and then drift management. So there's all these different things that are happening under the waterline, and that's really important. And that's actually, by focusing on that, the iceberg that's under the water or the engine that's under the hood, you can get basically a system that can do anything. All right, cool. Thanks, Dustin. You can get a system that can do anything, especially based on the data that it's trained on. So, to understand why data quality is so crucial, let's simplify AI at its core. So, you can think of any AI system, whether it's recognizing a cat in a photo or generating a coherent sentence, as a sophisticated mathematical function. Now, you heard my bio. I was not a math major. I was a Marine, which means like I can count to 20 if I have my shoes off. So, I'm going to talk in math equations, but like, bear with me. The function is what's important here to take away, okay? So, if you're looking at an equation, y would be your prediction, the prediction that the model gives you. And the model would be f. So the function of the model is based on your data. So the prediction you receive is a function of the data that you input into it. And this is a fundamental difference from the way that traditional software was worked. So for anyone, has anyone here a coder before I okay, so there's a few coders here that really know a lot about this. The way this traditionally worked with conventional programming, and these folks can talk about it, is you coded every single step of the way, right? You said, if the user clicks this button, then do that. If the temperature is above 70 degrees, and it was very rules based, if the temperature is above 75 degrees, turn on the AC. So the coders that are in this room are the people who are the people who truly crafted the logic behind this. But with machine learning, the game changed. Instead of writing the rules, we provide examples, and the machine infers or learns the rules itself. So if you think back a second to the iceberg slide, for a long time, the dominant paradigm in AI research was model-centric AI. So you hold in model-centric AI, you hold your data set fixed, and then you relentlessly tweak, optimize, and invent new algorithms, model architectures. Basically, it's like you think of it as, hey, my self-driving car isn't driving well. Well, let's add more layers to the neural network. Let's try a new optimization algorithm. And this led to some incredible breakthroughs. That's why we are here today talking about this. We went from simple networks and now into these deep convolutional networks and transformers. But over the years, now we've seen a different paradigm emerge and an equally important one emerge. It's the idea of data-centric AI, and that's what we're going to go into here for a little bit. So in data-centric AI, you can almost keep your code or your model relatively fixed, and instead, you systematically improve the quality of the data that you have in your model. It's a little less glamorous than saying you invented a neural network, but it's proving incredibly effective and in many cases, more impactful. So that's the movement we're going to focus on tonight. So we started with AI being the broad goal of replicating human behavior. And from here, we're going to go into a little bit about machine learning, which is the framework that's used to find patterns in the massive amounts of data we collect. Machine learning, if we parse it out, has three separate categories that are good to talk through. First is supervised learning. So when you think about supervised learning, this is the idea of learning from labeled data. The commonly thing would be if you think about like a child's brain, you show it 100 pictures of a cat, it can probably recognize a cat if you show it and you tell it this is exactly what a cat looks like. When you show it the 101st picture, hopefully the kid might understand that that's a cat. It's really amazing as someone with a 4 and a 6-year-old, it's amazing that when I say draw a giraffe, she knows instinctively to draw the giraffe with the long neck, and she knows that's a giraffe. And that's because she's been fed without, like, not in the same way we feed a model, but she's been fed labeled data because we've said, this is a giraffe. This is what a giraffe looks like. She fed giraffes when she was 2 years old in Kenya. Like, she knows what giraffes are, so then now she knows how to draw one. It's the same concept when you talk about supervised learning. You show a model an enormous amount of data, and you tell it that that is the correct answer. And with that, you can do it will then predict the answer when shown when shown all of that. Unsupervised learning is really interesting. And when you think about unsupervised learning, it's the idea of you give unlabeled data to a model or for machine learning, and it finds patterns within that unlabeled data. A great analogy to use for this would be if you handed a kid a coin bag and you said a bag full of coins, and you said, nickels, pennies, dimes, quarters, separate these out and put them into what makes sense to you for clustering. And so the kid may say, okay, great, I'll do them by size. I'll adjust them by color. I can adjust them by what has ridges and what has smooth edges. The kid doesn't know at all that these even have a monetary value, but instead it's finding these hidden structures and groupings within that. And it's really fascinating to use this with models because oftentimes it can find patterns in data that you didn't initially know was there. And lastly, you have reinforcement learning. Again, using my kids as an example, using kids as an example just because I got two of them and they dominate the majority of my life these days. The example of this would be if you give your kid a bike and you say the pool's a mile away, now ride your bike to the pool. So you've given it a goal, an optimized goal, which is find the best route to the pool, and say there's ice cream at the pool. So there's ice cream, there's a reward, and you say find the route and use this to get there. So the kid the agent, or in my case the kid, is going to take actions in an environment to maximize the award. Maybe the kid the first time goes down streets that have dead ends. Maybe your kid falls off the bike a bunch of times and bumps his or her knee on the way. But the second time you tell your kid to ride to the pool and get that ice cream, maybe there's less dead ends, and it goes through this cycle several times over and over again on repeat until it now has optimized the best interaction. And that's where reinforcement learning is. So for me, I like to use maps. Again, Marine, it's easy for me. So on the left here, we have supervised learning as an example where you feed the model a bunch of training data. So urban, forest, water, that you tell the model this is what that is, and you say make a prediction, that output. And so the model learns from explicit examples to classify new data points. Here in the middle, you see this pattern discovery where the model has actually found patterns that don't exactly match the idea of urban, forest, and water. And then lastly, the idea of a drone. So, if you think about like the agent or the drone here in this case figures out that it needs to avoid these obstacles to get from point A to point B and do it in the fastest, most direct manner. And it gets an award through that interaction, which is a successful delivery. Okay. Something that I want to talk about, another thing that just thinking through AI and some terminology that you may hear. You hear about Gen AI and you hear about agents. Has everyone seen AI agents in the news, or not news, but like advertised, that kind of thing? Yeah. It's another one of those. I don't want to say it's not a buzzword, but it's one that like you hear about. So I want to take a moment to talk about it, just in case people are like, well, what does this really do? So Gen AI is a creator. And an agent is a doer. Let's break this down. Again, giving some ideas as to how this goes. The focus for Gen AI is generating this new content. So if I say to Gen AI, give me a menu for this week. I have a 4-year-old that will only eat hamburgers and a 6-year-old that loves spaghetti bolognese. Give me a menu for the week and all the ingredients that need to go into it. That's the Gen AI, ChatGPT, Claude, any of those can produce for me this list, this menu, these recipes, and send it back to me and say, and it probably even end up with a follow-on question to say, would you like me to give you the recipe for a better spaghetti bolognese or whatever, right? Now, the idea of agents is something that started to really come to light in 2025 and is going to continue on through 2026 and beyond. And this is the idea of the doer. So in this, if you think of the recipe metaphor, the next step would be like, the agent to say, it's now in your Instacart, click this button to hit purchase. And the agent does that without you having to even, without you having to say, then like copy paste this. Like right now, it's like Gen AI, Claude gives you this answer, you copy paste the list. Maybe you have to go manually into your Instacart, add everything, add the quantity. So it adds up and you're like, okay, well, the recipe was in ounces and then there was in cups and then this is an ounce, this can's in ounces. How do I infer that? The idea of agents is it's going to do all of that for you. And it's going to be, and ideally it's going to be able to do that. And so in the end, it helps you the idea with an agent is it can actually do some of the like complex tasks that you have to do to free up you to work on how to direct it from there. So it's a really interesting development that's coming on. And we're going to see it really continue to take root as it goes forward. To be very honest, it's not there yet. There's a lot of things that like still very much need to be developed. So no one like freak out that like when I go to ChatGPT, I'm going to now have it all go to my Instacart. It's very much not there. But I think that we are going to be seeing this in the future. We know we're going to be seeing this in the future. So when we talk about data quality, what exactly do we mean? Okay, so going from left to right here, it's really more about it's not just about having more data, it's about having better data. And when we break it down at scale is into four main pillars: the quality, the consistency, the diversity, and the quantity. So quality seems obvious, but it's very hard to achieve. Information in your data set has to be factually complete, factually accurate. The text has to be factually accurate. Is the label the most detailed classification possible? So if you all will see this when you use the computer, and you'll see it in a later slide. Have you figured out what is the most detailed description of the object you're looking at? And then, are the spatial measurements of that object accurate? So in St. Louis here, we have a workforce of a couple hundred folks, like I talked about early on. A lot of them work with geospatial imagery. We have built out, and we have a lot of folks that work on text samples within that as well. They help do some generative AI writing. So within that, we've actually identified those people that have a higher level of maybe not higher level, but they have a talent for it, and they have an ability to identify the high quality submissions and ensure that everything that leaves our center is as accurate as possible. And then we've also have people such as Dustin with 20 plus years who are sitting there even confirming our workflows to make sure that all of our geospatial imagery that goes to the government is the highest quality and is 100% accurate. These are the unsung heroes to make sure that our quality is always the greatest, that is always the highest level that goes to the U.S. government. Same thing, that's on the geospatial side. It's the same thing on the writing side. Those folks are making sure their grammar is accurate, making sure that the writing samples are consistent, they're thorough. Which brings me to my next thing, which is consistency. This is critical in complex data sets. So are your labels uniform across the data set? If it's text, are the values for a specific item the same? So when I say bank, when I say bank, what's the first thing that comes to mind? Oh, the place where I put my money, right? Also, it could mean a riverbank. It could be banking on a turn, right? So there's a lot of different terminology, and if you're not consistent in that, then the model will struggle to learn which meaning applies when, which leads to confusion and unreliable outputs that come from these models. Third, we have data diversity. So does it cover the full range of scenarios? A good example of the importance of data diversity is when you think about autonomous vehicles that are driving around cities. A lot of cities about 5-10 years ago, all of a sudden you could rent. For those that have been to there's some cities that have scooters that you can like get on a scooter and like rent it for the day and ride around. Well, all of a sudden autonomous vehicles saw people kind of floating in the air, right? Because like they just see a scooter go by. That's not the way a person is supposed to move. And the autonomous vehicle doesn't know what to do. And these are these weird edge cases that like now became everyday life. And so what's really important with data diversity is training those models on the wide range and the edge case objects, because if a scenario isn't represented even sparsely in the training data, then the model simply won't know how to react. Data quantity is the last one. So this is a really interesting one where these models are trained on thousands to millions of images or thousands to millions of layers of text to be able to ensure that the outputs are accurate and to avoid a data imbalance. So basically, these examples that go in, it's assessed empirically by learning curves, and then we validate the performance to make sure that enough data is in the model to get the answers, to make the model deterministic, which means you know that it's going to give the same answer every single time. And so if the performance plateaus, we know maybe we don't have enough. If the performance plateaus, maybe additional data isn't necessary. But the ideal is to give it enough data that it can reach that point that continues to give you repeat of the answers that you're looking for, reliability. Okay, so I'm going to go into this a little bit to not get too technical, recognizing the audience that's here. The thing I want to point out here is that it doesn't just end when you finish training a model on those different pillars that I talked about data quality. There's also the idea of evaluation and monitoring. So there's an iterative feedback loop, because when a model fails, so again, the self-driving car, so my son who spontaneously decides to wear a dinosaur costume on a random Tuesday, a self-driving car, it might think that's a dinosaur crossing the street and not a person. That's a problem. So the model should be identifying these errors, and so the model deploys. There's these error analysis, there's data audits and unit testing to figure out exactly where do we have enough data? Why was it there? Is it specifically on when a 4-year-old crosses the road with a dinosaur costume on? And then from there, the ideal is to do a targeted collection. So we need to identify more 4-year-olds with dinosaur costumes and do a relabeling. And so now apply labels to those people and then deploy that back into the model so that the model can go back through and ensure that this is not a failure mode. And continue. This is a continuous cycle. So the continuous cycle. So this is not a deploy data and done. It's deploy data and analyze errors, do some auditing, do some testing, and then move into collection, relabeling, and then deploy it again and figure out where it went. And it just continues on. So I've talked about, and this is how that works. Now to dive a little bit deeper into the two different types, being computer vision and large language models. I'm going to start off with computer vision and to kind of go into what exactly does data labeling look like. So if you look at these boxes, and this is where Dustin's going to come up in a little bit here and show this to you. These are the idea of drawing what you hear about bounding boxes. You may hear that term if you ever study AI. You hear about bounding boxes, and these are the boxes that are drawn around objects to be able to identify them. They have to be tight. They have to be on the object. There's precise object classification of the idea of this being a passenger plane versus calling it an aircraft. So if you call it an aircraft, well, there's a lot of aircraft. So how does the model know if it's looking at a passenger plane versus an F-35 versus any other aircraft that you're looking at? So what's the level of class that you need it down to? And then from there, ensuring the bounding box is as tight as possible or as tight as it needs to be. And that depends oftentimes on the accuracy you need the model to have. So there's no single, this is a big, it depends, which is my favorite and least favorite answer. But what you can see here is the gold standard, and then this is the cost of imperfection, which is an aircraft. So if you feed a model something that has a very broad thing, the model may give an unpredictable answer, or it may give an incorrect answer, or depending on your use case. If you say, I want to know what aircraft are on this field because I need to do humanitarian assistance because there's a hurricane in the Caribbean, for example, I want to know what aircraft are fully functional on this field. A model that goes over that may not be able to accurately identify that it's looking at passenger aircraft because it wasn't trained the right way, if it's not trained the right way to the correct use cases. When we talk about large language model, there's a great term that's used, and you hear it for computer vision as well, but the idea is garbage in, garbage out. So ChatGPT, all these, we talked about the idea of quantity. These models are trained on a colossal amount of text data that are often scraped directly from the internet. And the internet, everyone knows this, but the internet's a really messy place. That And like, thanks to social media and a lot of other things, it's created a lot of opinion. You have biased content, maybe there's outdated info, messy data, factual inaccuracies. These all exist. And so you have garbage in, garbage out. So when these things go in, this uncurated internet data comes in, what does the model put out? The model doesn't know any better. Think of the model as, any gaps or biases, they make their mark later on down the road. And so when you put this into the model, what comes out of the model? The model puts out things such as misinformation, stereotypes, harmful content. I think we heard a lot of this in early models. You heard of a lot of this, especially on some of the early models that displayed a lot of these biases. Some of them were very politically charged. I'm not going to go into them, but I think that for some in the room, that may have led to some initial distrust of the AI or the model itself, because you're like, well, if I use X model, it will give me an answer, and that answer is probably, will have a stereotype or harmful content or all those other things. And so the model developers who we work with every day out of scale are ensuring that they don't have this garbage in, garbage out scenario, that they're working with the high quality data sets that are grounded in truth and not grounded in the bad stuff, to use a non-scientific term. Okay, cool. And then lastly, this brings us to the hallucination gap, which hallucinations, who here has heard the term hallucination when you talk about AI? Like everyone in the room, right? And it's like the great fearful thing of like AI. You hear it all the time. I heard it from my mom and my mother-in-law, who were in separately, but they still both talk to me all about the hallucinations. And so there is this hallucination gap, which is basically the idea that a large language model. So when we talk about like your ChatGPT, large language models, and that's just an example, not to say ChatGPT hallucinates, but when it encounters a query for which the trained data is sparse or conflicting, think back to the bank question, when it receives that, or it's simply like non-existent, models don't say, I don't know. They instead try to fill the blanks with plausible sounding information, and then they sound really plausible, right? Like you're like, sounds like the answer, but it may not be. And that's the hallucination. So the poorer the quality and completeness of its training data, the wider this hallucination gap becomes. And so the model generates believable lies, not malicious, but because the learned patterns allowed it to construct coherent sentences, even when it lacks grounding in reality. I think what's really interesting about the hallucination gap, to talk about this for a second, is a lot of times model creativity depends on your use case. So when you think back to what I talked about with the aircraft, if you're using a model and you want to ask the model, like, what are the aircraft in this? And you are using it, say, for instance, if you're from the national security sector, you need it to be accurate as to what aircraft it's looking at. So if the model is inaccurate, if it hallucinates and gives a wrong answer, that's a big deal. But if you say to the model, hey, use some creativity and come up with what I should give my workforce for a Christmas bonus based on historical data that's in there. Well, the model, having a model that has that ability to be creative and is not too tightly wound, is actually really important, because it can think through some of the creative things that you could do to meet your objective. So hallucination gap is really an interesting thing, because there's two very different cases in here that it really depends on how you're using the model in terms of the ability to allow a model to be creative. So I want to take a few minutes and go over. I think how are we doing on time? I think we're doing okay on time, right? Okay, so I'll take a few minutes here to just do a bit of a quick demo, just sort of on the models and some of the things that we do. So I'm going to be using an image that I took off of Google Earth, easily found. It's at Engels Air Base, which is a Russian air base. I used the ability for Google Earth to go back in time a little bit, because it's obviously changed a lot over the last couple of years. So I'm going to go into Google Gemini, and I'm going to say, here we go. When was this picture taken? How many aircraft? And we're going to upload this file, which is the picture right here. And I'll pull it up for everyone to see. So let's see if that you guys can't see that. That doesn't help you at all. Give me 1 second. The problem is, see, you can't stop humans from making mistakes, though. Is the problem. Okay, so there we go. Agree. What files? Okay. So here we are. We're in Gemini. We've taken a screenshot of Engels Air Base, and you can see how many aircraft do you all see in this picture? 4. Whoever said 3, it's the lighting. It's not you. But you get credit for speed. So speed is important. So there's 4, right? No one here does geospatial intelligence. No one here. So we knew that there was 4 aircraft in this picture. We all got it right. Exception for said 3, but there was lighting. So we're going to ask the model, where was this picture taken? How many aircraft are in the picture? What type of aircraft is it? And how do you know? So these are the questions you're going to ask this model. Okay? And the interesting thing about Gemini, this version of Gemini that I'm using right now, is that it has the ability to kind of use this drop down here of fast, thinking, or pro. And so the model, there's really an art and a science here that a lot of the model developers are using, where they recognize that if it takes too long to get an answer, then you may not come back to it or you may not use it again. So Gemini offers you this on fast, but that also means that it goes through the data fast and it may not find the answer you're looking for. So let's start off. First, let's try it on fast. And we'll hit go, and it's thinking. And while it's thinking, I'm going to come over here to ChatGPT. I'm going to ask ChatGPT the exact same question. And I'm going to attach the same image. It's uploading. There we go. Okay. So ChatGPT is thinking. Let's see. Okay. And see, this is the challenge right here. So Gemini has just spit out the same image I just showed it, and it didn't answer my question at all. So some people see that and they're like, well, maybe I'm not going to use it again on this one. So let's try creating same thing. Enter the prompt, same question, same questions. Let's see if we get anything better with the thinking. And while that runs again, here we go. Okay, so how many aircraft? 6 aircraft in total, 5 fighter jets, and 1 large transport aircraft. The fighters are Su-27s. Here's how I know. The transport aircraft is an IL-76. Where was this taken? At a Russian military base. So we know it was at Engels. I know it was at Engels because I found that in Google Earth. But ChatGPT, through that, can't get it, they can't confirm it because it's too small of a map chip for it. Okay, got it. Now, Gemini is interesting because Gemini, and so this is really funny because I actually, to be clear, I tried this out several different times and got the right answer a lot of times from Gemini, and now it has given me completely the wrong answer, which is fascinating. So this comes back down to this idea of deterministic versus non-deterministic, which is the idea of repeatability is a huge challenge that the model makers are still going through every single day. And so where was this picture taken? How, how'd you come up with this? And so, okay, so this is saying RAF Fairford. There's 4 aircraft, so got the aircraft right. What type of aircraft? It's a Boeing B-52. It's not a Boeing B-52, I promise you, not parked at a Russian airbase. And then we're going to break national policy here. And this is how it knows. Okay, so now I ask the human that spends every single day that has spent every single day of his life of his adult life looking at these, Dustin, what am I looking at? How many aircraft are in this picture, Dustin? And what type of aircraft is it? There you go. Russian strategic bombers. They are not fighter aircraft. There are 4 of them, so we got it right. And then you have this idea of you have someone such as Dustin who knows that. Dustin can spend a long time and actually gives people who join our workforce weeks of training to make sure that they know the different concepts of how you identify that. And it's amazing when you see people who start who are like, oh, I was a nurse working the night shift and I was really tired of working the night shift because I had not seen my partner in a year. And then like 2 weeks later, they're like, oh, that's a Tu-95 Bear, and I know that because the wings are here, the engines are there, the weft is the term, and I got that right, but I can't tell you what the acronym stands for on the top of my head. It's my failure. So, but because of people like Dustin training people accurately every single day, that's how we know what these are, and that's how we correctly identify these. What's important though is these models have to also be trained by this data to get this, to make sure that this is accurate. I don't blame Gemini or ChatGPT. These are very general use models, generalist models. This is not their fault. They're not necessarily trained on this data or on this level of, probably not on the same quantity of data or diversity of data to get this right. It's really interesting that Gemini got it right every other time. So there's also this idea of the ability to segment anything, and they've got this playground called SAM3, which is a Meta app, and you can see how the models can identify what's there. So here is same image, and within that we say, okay, identify all the aircraft. Okay, so the model, it's amazing, it comes back really fast. So again, speed, very good. So it identifies the aircraft. It's drawn, instead of bounding boxes, it's kind of drawn these weird like shapes around them, but pretty accurate. What's really interesting though is if you get up top here, you'll see it, like it actually for some reason mixed in the shadow. So if you now feed this into a model, if you think back to our like our accuracy pillar, that you need to feed a model with the most accurate information, and you, even if you get it right and you say, okay, these are all in fact Tu-95 bears, but you feed this into a model with the way this is, well, the model is actually going to then identify that this shape is what a Tu-95 bear looks like, which is not the case. And so it's really interesting when you think about that. And that's why companies like Scaled, why we exist and why we have our workforce that has been developed over the last 4 years, is because we're not at a point yet that you can just put this into a model and get 100% the correct answer 100% of the time. The reliability is not there. And that's why we have people such as Dustin to make sure that we can accurately identify them. And Dustin's looking at a lot of the data that comes out, almost all the data that comes out of our office, to make sure that that comes out correctly. So to close this out and then hand it over to Dustin so you all can hear him speak, let me just pull up my last slide here, and then I'm going to turn over to Dustin, or turn over to questions and then over to Dustin. Okay, so last slide, and then to kind of sum up a little bit here. Okay, first, I hope I've made a compelling case to everyone why data matters in terms of building better AI. And that's really what Scale exists to do. The secret sauce behind many of the most successful AI applications isn't always the most cutting edge model performance. Often it's superior data engineering. That's the meticulous, painstaking, and often unglamorous work of collecting, cleaning, labeling, augmenting, and managing these high quality data sets. And that's where real value is being created and where many of the hardest problems of AI are being solved. So we are reaching the limits of the existing world knowledge corpus. So we're going to increasingly shift to exquisite data and even proprietary data. And as we move into that shift, companies like Scale are increasingly important, because we make sure that when we are training a model with a company's proprietary data, their model is trained on their data, not on the corpus of the internet's data. These companies, we help people using the everyday AI. Everyday people using AI can have that assurance that they're using the highest quality data sets are going into these models that exist right now. Scale works with all the different model makers, from ChatGPT to OpenAI to Anthropic. We have partnerships with all of them. To summarize, you can take a mediocre AI model, feed it truly excellent, clean, diverse, and accurate, high-quality data, and it will almost always outperform a perfect or state-of-the-art model that's been fed mediocre, messy data. The data sets the ceiling for your AI's performance. For the scientists, technologists, students in the room, as you embark on your own AI projects, I really urge you to recalibrate your focus. Instead of spending 80% of the time, endlessly tuning models and working through that, consider spending 80% of your effort on the data pipeline and how you collect, process, and ensure the quality of your data. And 20% of the time, selecting and fine-tuning your model. I think you'll likely find that this data-centric approach leads to far more robust, reliable, and impactful AI systems. Thanks for your time, everyone. I'm happy here to pause and take any questions that you may have. And yes, sir.
So some queries could include change over time, and we're seeing lots of examples of data scrubbing. So how do you deal with that, or how does the technicians or the model deal with if data's removed?
When you say data is removed,
The government is removing data on climate change.
so the models are trained on the data sets that the model makers see are important. So what I would say too, though, is there's not a single source of data that's there as well. So when you talk about the idea of uh, a single party maybe removing any data from the internet, that doesn't necessarily limit how a model may answer that question.
So there's situations in which the foremost data collection center on climate change in Colorado is potentially going to be shut down. So do people go in and try to scab it or take that data out before it's eliminated?
I mean, I can't go into exactly how all of that works, but what I can tell you though, again, is that the models are not looking at a single source of data. And that's the thing that I think you can be really sure of. The other thing too, is that just because it is removed at a single point of time, the internet, there's literally the internet goes on forever, right? And the history of the internet goes on forever. So there's a lot of mirrors of those types of sites that exist. So I can't tell you that how a model is going to respond if one site goes offline versus not. But what I can tell you, sir, is that the if you're concerned about how a model is going to respond, I can tell you that it's trained on a lot of data and it's not looking at a single source, but we have a lot of sources of truth that help to inform those models. Yes.
So you mentioned the data on like enterprise company, private data, they won't share with the public, right? So,
right.
So today we don't have much data on the internet left for all the models to train.
Yeah.
So all the value actually lives in enterprise companies,
right,
governments, all that. So I'm just thinking, how you guys still AI company help the private companies, government to scale all this data quality work. I mean, you mentioned Dustin many times.
Right.
I feel Dustin is bottleneck.
I feel that way. No, I'm kidding.
It's like we need people, right?
Right.
In this case, we need a lot of people
right.
to clean the data for so many companies. How can we scale that?
Yeah, I mean, that's a great question. That is a great question of how do we create this high quality data and how do we work through what those data sets look like. I can tell you that, especially scale on the enterprise side. So the enterprise side being this idea of working with other businesses for the room, like the enterprise side being the idea of working with other businesses on their data. So if you think about a mortgage company, and that mortgage company has millions upon millions of documents that, if you helped to feed the text of that, maybe that mortgage company could work through even the idea of creating an agent that can help to fill out a ton of the mortgage. As someone who recently signed a mortgage, those thousands of paper that we all sign every time we sign one, maybe an agent can create those instead of an individual person who does it. With that in mind, I think what you're getting at is really the crux of it all, which is it comes back to those 4 pillars of data, which is the idea of understanding. The great thing about scale is we have these experts that work every single day in this to understand exactly what is the quantity of data. And what they do a lot of times is they work with, I just was watching a kind of presentation by someone from Scale was talking about how they work with these folks, like the enterprise folks. They identify what are the quick hits where they see immediately that once you input this data, they see an immediate model increase, a model performance increase. And they know that that's where, okay, now if we apply more quantity to that data, we'll see even better model increase until it plateaus. When we talk about how, Dustin being a bottleneck, Dustin is a bottleneck because there's not a lot of Dustins in this world. You're right. That's why we came to St. Louis, and that's why we created 250 jobs here. It's because we took all these folks and we said, okay, cool, you're really good at puzzles. Let me tell you what you're also probably good at. Looking at synthetic aperture radar imagery and identifying a naval vessel. And shockingly, they are incredibly good at it. And some of them who spend 8 hours a day working for Scale and then the other 8 hours a day designing their art or doing photography, those people are now we've eliminated the bottleneck where Dustin now can be an auditor, and Dustin is not the single source of truth. He's making sure that people who are the source of truth, they are doing their jobs right.
So instead of model training, we have human training.
Yeah, exactly. And we've created, we've created careers out of this, right? So we have people who came in at the entry level and then and now they've graduated their way up to becoming reviewers where they became as geospatial AI trainer level ones, and now they graduate up to level 2, level 3 team leaders where they're leading teams of AI trainers doing this, and then now they can go to University of Missouri St. Louis, get a GIS degree from there thanks to the educational partnership we have, and maybe from there they move on to working at, say, any other government agency that does geospatial. Yeah, great question. Thank you. Yeah. Yeah. I can't speak to meteorology directly. Again, former Marine, but like it's usually you look up and it's raining right now. We're still hiking. It's still wet. But no, what I would say is that like as you see this, like we saw today, we saw 2 models that came up, 3 different models that came up. 3 different models had 3 different answers. None of them were right, and that's not the model's fault. That's because these models are general models. But you get the point, though, is that yes, oftentimes it's the data that the model's been fed on, and it's the person reading the outputs. Yeah, I mean, in our workforce, we reward the attention to detail. So the ability to attention to detail, the ability to see complex patterns. For those that have never seen synthetic aperture radar, it is like looking at the static of a TV. For those of us that are older than like myself, but or same age as me, where you've seen the static of a TV. Somehow you look at the static of a TV and you can go, that is a thing, and you're like, that's amazing that you even knew that. So I'm constantly shocked and amazed. You're like, so what did you do before scale? And they're like, oh well, like I was a barista. And you're like, yeah, that's a natural move into the AI field. But it's amazing the things that they do. Please. It's a great question. I mean, again, this again comes back down to those 4 pillars, right? So if Gemini hasn't seen, if it hasn't been told, hey, this is a plane a bunch of different times and from a bunch of different angles. So if you think about, like, I used to live when I lived in Kenya, the neighborhood that I lived in, all the stop signs were made out of wood. Like it's just how it's how the stop signs in the neighborhood were like made by the neighborhood association. They weren't the steel stop signs that we have out here in St. Louis. So if you think about like an autonomous vehicle, it's been trained on a ton of different pictures of what a stop sign looks like, maybe in America, but never in Kenya, where there can be a stop sign made of wood. And so it's the same concept when you think about these airplanes. Maybe it was trained on 1,000 different images of an airplane on an airfield, on Angle's airfield possibly, but maybe those airplanes were at a different angle, ANGLE angle than the ones in that picture. And so if you don't have that diversity of data and the idea, again, of edge cases, then that's when you can have challenges where it doesn't identify the aircraft correctly. We've seen even like, and this is all like it's been on the news that like there was a video of a tank from a specific country that was driving around where they had literally like put a house on the tank. And the reason why they do that is so as drones are flying overhead, not only is it camouflage, but it also can defeat a model because the model has not been trained to look for a house with a turret going out of it. Makes a big difference. Any other, please?
Is Scale doing any synthetic labeling where
Yeah. You can definitely use synthetic to generate the imagery, but I think that there's been a lot of studies shown, and I won't get too far out of my lane on this one in terms of like my knowledge base of this, but like I think some studies have been shown that like synthetic labeling, when you feed it back in, does not always necessarily result in a accurate response from the model. So synthetic labeling, for everyone to understand, synthetic labeling is the idea of using, like, if you use something like Gemini, you can say, maybe you don't have a lot of instances, back to Gemini here, you can go into, and what's really interesting, Gemini now has these tools like create images. So, if you think about, the cool thing about Gemini or some of the other ones is you describe something and there's an orchestrator now that goes into a menu and says, oh, based on this person wants imagery generation, and they will generate an image based on that. So in Gemini, you can type something like generate an image of a tank in a field with infantry moving toward a beach. And Gemini can, with this Nano Banana Pro, can create this image. And so you can create that, but it isn't necessarily always reliable in terms of the model training. And again, speed is a whole thing, but like what's really interesting is the way that you can see how quickly it actually is creating an image. And this is like, my dad moment where like I actually have my kids, I'm like, hey, create an animal for me. And like my kid will be like, create a rabbit, with fangs, and it's a red rabbit, and like you can really refine that. But here's what Gemini created in just a matter of seconds, which is really interesting. But what's really interesting too is like the infantry, like for those that, Marines or anyone in this room who serve, is like these are people wearing like World War II uniforms. They're not even wearing like current day's uniform. So like, how do you train a model on that? Like, that's great if you think your model might interact with like World War I or World War II soldiers. So if you want to put AI in a time machine, but it doesn't always work. I think that might even be like a Panzer or something like that. So yeah, so it really doesn't help. It's not an M1A1 Abrams. So you really have to be very explicit with your prompt that you put into the model, because the prompt is very important to get an accurate answer. Okay. It will not be perfect, but this is still impressive though. So like, let's not minimize it. Like in a matter of seconds, it created that imagery. And really in the end, I think like something to learn out of this that I would encourage everyone, especially like if you're just getting into AI or just exploring AI, encourage everyone to take the time to learn a little bit more about how to write prompts. Cause like that was actually a pretty poorly written prompt by me, because I should have said like, draw a picture of an M1A1 Abrams and a platoon of Marines from 2025 that are advancing towards a beach. If I gave the model that description, it might actually put out a much more accurate picture. So prompt engineering is really important, and it's something that I've taught my mom about, even where I'm like, hey, you are, when you type into your prompt, go, you are a pharmacist, you are prescribing this medication, you are filling this medication for this person. Are there any drug interactions? And I'm not saying use a model for that, but I'm saying you can if you want to like verify that. And by saying you are a pharmacist, you trigger that data. Okay, so we're about at time. I think I'm way over time. So what I want to take a moment to do is turn over to Dustin to introduce himself a little bit more while I unplug the HDMI and plug in the other computer that's got some of the data labeling. So Dustin, please.
Thanks, AJ. Hi. Good afternoon. As AJ mentioned, my name is Dustin. A little bit about my background. I was raised in Alton, Illinois, just right up the road, not too far from here. I mean, it is a little far, like 45-minute drive here. But I joined the Air Force at 18. Well, I say join, really, my mom was kicking me out of the house, kind of there. So I had to do something. I wasn't that smart in school, so I joined the Air Force. I was blessed where the Air Force put me into Air Force intelligence. So I did Air Force intel for 20 years, all imagery geospatial. So that term geospatial, not a lot of people actually know what that means. Basically, maps plus imagery, positioning on the world, where you're at, those kind of things is what we're doing. During my time in the Air Force, several deployments. I've been all over the place. Nothing like real cool, like or hard, like AJ had to do. Like he did like real Marine stuff. I had like your typical Air Force deployments. I was in Italy for a while. They sent me to Australia for a little bit. Just a lot of fun stuff. During my time in the Air Force, I taught the actual career field imagery or geospatial. I taught for them for the Air Force for about 5 to 6 years, and then did more deployments, more interaction with imagery. After I retired, moved up to DC. I taught at NGA. We also have a second site, NGA, those three letters, NGA. It's the National Geospatial Intelligence Agency. If you're not aware, here in St. Louis, you have the second largest NGA site here. They just built a massive, like, billion-dollar facility on the north side of the city. Gorgeous, beautiful. If you haven't seen it, it's really nice. They're starting to move in there. It looks really nice. I was able to transfer out here where I'm from. My hillbilly parents are still kicking it, but I was gone for like 25 years. They just need a little bit of supervision now, kind of thing. So I was happy to get back. My time in teaching, I taught for NGA. I taught for them for about 6 years. A lot of adult learners, just like yourself, people just fresh into the imagery career field, what they're doing. Segal kept hitting me up like, hey, we need a teacher here. We have this thing going on. We need a teacher. I was like, I kind of like what I'm doing. Finally, I was like, you know what? I'll listen to what you got. Give me your spiel. And they just wowed me over, right? Because one of the biggest points, the biggest things, the driving things. So I know he showed you that picture. AJ showed you the picture of those airplanes, right? Our bombers, those strategic bombers on the airfield. As an Air Force analyst, as far as like doing intel stuff, I spent so much time of my man hours, all that stuff, figuring out the what something is. What were those Tu-95s, right? I figure that out. I take time to do that. But really, we can let the machine figure that out, right? So that's what we're doing here at Segal, as far as one part of Segal. It's not all of Segal, but one big part of Segal is we're figuring out the what things are. So that way, when these models and everything, as far as like the Air Force, the Marines, the Army, any sort of Department of Defense, they can now do the what part. So then an analyst can spend most of their time on the why is it there? What is it doing? What is it going to do next? Right? Those other harder hitting intel kind of question sets that we're looking for. And past that, I was just wild, right? And so as AJ mentioned before, I teach for Segal. I teach the imagery course. Basically, I'm trying to take about 6 months of training and get it to in 2 weeks. It's tough, right? So wave tops. We stick with a lot of wave tops, just what things are in general. And then we start every week, I'll host a class, a very specific class on something, such as these ships that you're going to see. Like, oh yeah, let's learn that this is a certain type of Chinese vessel, right? What kind of Chinese vessel? Let's just narrow it down. It's a surface vessel. Okay, past surface vessel, then what kind is it? Is it a destroyer? Is it a frigate? Is it a cruiser? Oh, it's a cruiser. Okay, what kind of cruiser? Then you keep going down. Think of it as like another example I like using with that. Everybody's got cell phones now. Almost every one of you, I almost guarantee, have a cell phone in your pocket, right? So you start at the top though, communication. And then from communication, where do you go? Is it written? Is it text? Is that? Let's just stick with the phone thing, right? So let's just say, okay, I have a phone. Okay, what kind of phone? Landline, cellular, analog, satellite. Oh, I have a cellular phone. Okay, you drop down to cellular phone. What kind of cell phone? Is it an iPhone? Is it Samsung? Is it T-Mobile? Whatever. I don't even know if they have. But you see what I'm getting at? You keep going down that rabbit hole. That's what we're trying to teach the model to do. So we could stay big, right? That thing was able to identify aircraft. It couldn't say how many for some reason. I don't know why. It's probably just because there wasn't a lot of data thrown at it. Maybe they only did 100, 200, 500, 1,000, maybe examples of what that bomber looks like. Probably not enough to actually learn what something is. All right. What we do there at Segal is we're going to look at those same images. Like let's say this whole room. I'm going to have all you guys look at that same airfield, and you're going to label those Tu-95 bears thousands of times, over and over again, looking at it at different angles, different times of day, different lights. You saw that it got confused with the shadows, right? So we'll teach the machine to ignore that part, right? It's all based on pixels and where it's at. That's why you have to get those boxes in pretty tight, just so it doesn't get all that noise on the outside. And it's constantly you keep teaching the machine, the better it gets. And then what AJ mentioned before, like one of my jobs is like the final like QC for it all, is because with these kind of situations, one bad label can wreck 500 good ones, just because it's learning. It's like, well, the machine's like, well, you said this is also bad. That contradicts everything else you just taught. So you have to be very careful. So data in, data out kind of thing. Garbage in, garbage out. Y'all want it to be good. Stuff like that.
Do you want to go over? So what we have over on the side, and as soon as we end here, we'll get those computers up and running. And so what you're going to have on the side, and what Dustin's here to help out with, for those that want to take a few minutes to work on this afterwards, for those that have the time, you can go through and see how labeling actually works. So if you want to go hands-on to see exactly how is AI trained, you have the opportunity to come in and draw bounding boxes. So you just it's actually like honestly like amazingly simple. I hope you all didn't watch me struggle with it as I say that, but there's tools behind this. But so basically, you can say you identify this, and then you have your crosshairs. Let me turn the crosshairs on, because it'll be easier for you to see from a distance. Okay, so you have your crosshairs, and then you draw a box. You go, okay, here's my box, and then you have to pick a label for what it is. So what am I looking at here, Dustin?
It's just an auxiliary vessel.
Auxiliary vessel. So you type in auxiliary general intelligence.
So the labeling thing, it says auxiliary general intelligence. That's not right. It's just auxiliary, meaning just support.
Yep.
That label name isn't in.
Yeah. So this is using a little bit of an old data set, but you can see what this is, and then you draw a box around it. And this is what our people are doing every single day. And you're trying to get the box, again, like Dustin said, as tight as possible with the pixels. So what we'll do here is we'll get unlocking these and logging into this. And as we get done here, I'm happy to answer some people's questions offline if you have them, as well as the fact that if you want to take a few minutes to see exactly what someone does when they're drawing these bounding boxes, what our folks in St. Louis are doing every single day in downtown are doing every single day when they're in the system. Please feel free to take the time to do this. Cool. Thanks, everyone. It was great to have you. Great to meet everyone. Appreciate it.